we're going to take another look at using the frequency function, and here we have a number of people's heights enlisted. So we have 10 rows and 50 columns, which means that's altogether 500 heights. We would like to see how many people have different heights, and for that we have written down that we want to see what is the minimum, the maximum of those heights. Let's select all these 8 cells and let's give command formulas create from selection left column, and let's write down equals min, which calculates the minimum, and let's take this block here, equals min. So we see that the smallest height is 160 centimeters. Now let's calculate maximum with max, and we have 202 is the tallest person. Now something we need to do very often in such situations is we need to decide how many steps in our analysis are we going to take. Since it's from 160 to 202, seems to be 42 centimeters. Let's say that we take 21 steps. And now we need to calculate how long is one step. So we are going to write down a formula equals, and we at first need to calculate the length between the tallest and the shortest person. So we write equals maxim minus minim and press enter, and here it is. It's 42 centimeters. This is the length of our observation, and now we just divide it by this number of steps, and we get that one step has the length of 2 centimeters. Okay. So this is one very common formula. So we write the length of our different heights traversed, and we divide it by the number of steps we take, and we get how big the one step is going to be. And now in order to write these numbers down, we write here equals minim. So we get the first height right away, 160. And now the second formula, which is also something we're very familiar with, is that the second formula is going to write equals previous plus step, and as we've done before a few times, we can now copy the second formula until we reach 202. We seem to have this situation where Excel doesn't calculate everything right away can be solved from formulas, calculation options, and now it's okay. Sometimes some big calculations take so much time that people switch off some calculations in their computer, and this was done right from there. Okay, now we need to give the command frequency. So let's, as always, select these cells. We need to select one extra cell actually. Let's talk about this one extra cell later. And we write equals frequency, parentheses begin, and that's our data is up there. So let's at first select our data, and then semicolon, and we want to next select the heights that we've calculated. The different heights we want to analyze the data by that we've calculated already. And now we need to press Ctrl Shift Enter, and here we go. So let's once again go over what frequency exactly shows us. For instance, this number 6 means that there are 6 people who are over 168. They might be 168.1 even, although not in this data, as it seems to be. because here are only integers here, numbers without decimal places. So 6 people who are over 168 until 170 included. So this 170 is included, 168 naturally isn't because it belongs to the upper row. So 6 people over 168 up till 170, and we can also say that, for instance, 22 people are over 190 and up till 192. And now, when we calculate those numbers like this, we naturally get to the last number. This last number shows how many people are all on the other side of the last bin. So everything over 202 is listed here. Actually, in our system, where we calculate this minimum and maximum and number of steps and then go from minimum to maximum, the number of people over maximum is always 0. But we don't necessarily need to calculate it in this way. We could have just written like 160, 170, 180, 190, 200, and then there would have been a few people over 200. So we sometimes need this last cell. And frequency formula ordinarily has this last cell as well. And now, in order for us to draw a graph here, we select all these without this last cell, and this seems to be a scatter graph because here it is, the x-axis has heights and how many people with that height are on the y-axis. So we do a insert and scatter graph, and here we go. This is something which really closely resembles the normal curve that we've seen already. Normal curve meaning that the middle height is mostly represented, and the taller or the shorter the person is, the more less frequently he really appears in our data. Okay, so we can now delete this series 1 here as well. And this is our graph.